Hey everyone, so in this video we're going to continue talking about confidence intervals, but this time we're going to talk about the t-test. So just a reminder, whenever we do the PANIC acronym, whenever we're trying to find confidence intervals, the only difference whenever we make the assumptions was if sigma was known or unknown. So when sigma is known, that's when we do the z-test. That was last assignment. However, if sigma is unknown, then we use the t-test, right? And just as a reminder, sigma is the population standard deviation. Population standard deviation. All right, so for this one, we're going to have sigma be unknown, but instead it's going to give us the sample standard deviation, which we're going to call S. So we're going to do the exact same thing, the only difference being that instead of confidence.norm in Excel, it's going to be confidence.t. All right, and in that formula, whenever it says standard deviation, it's talking about the sample standard deviation, so S, not the population standard deviation, because if we had population standard deviation, we'd be using the z-test like last time. Okay, so with that said, let's go ahead and take a look at example 1. So example 1 is going to be very similar to example 1 last time. The difference is what test we're going to do. So David decides to try and estimate the mean score on math tests for the whole college. He samples 35 random students and finds their mean test score in math to be 79.2 and the sample standard deviation to be 14. Assume the scores are approximately normally distributed. Construct a 90% confidence interval for the test scores. All right, so first off, P is our parameter of interest. So it is the mean math test score. All right, A is our assumptions. So first off, it is random. Secondly, we have 35, so n is greater than or equal to 30. And it's also approximately normally distributed, so and normally distributed. And then lastly, we don't have the population standard deviation. Instead, we have the sample standard deviation. So sigma is unknown. So for the type of test, or the name of the test that we're going to use the t-test. And that's all because of this right here. All right, we don't have a population standard deviation, so we use t-test instead of z-test. All right, so for the interval, let's go ahead and head over to Excel. And in Excel, I did go ahead and put in our mean, our S, which remember that S is just our sample standard deviation, N, which is the number of samples we have, and our C, which is our confidence interval, which was 90%. So I did just put all this over here just so you can see it while I'm doing this. Remember, we don't work with C directly. We work with that alpha, which alpha was just 1 minus C, which is 0.9. So we know alpha is 0.1. So we want to find our E, All right, remember that was that margin of error that we're going to subtract and add to the mean to find our interval. So again, this is going to be equals confidence, and then we're going to do confidence dot t. All right, so instead of confidence dot norm, we want confidence dot t because it's the t-test. Then we just start putting in everything. So our alpha was 0.1. Our standard deviation, which is our sample standard deviation, was 14. And our size was 35. Hit enter and we have our margin of error. For our lower and upper bounds on the interval, we just do the mean minus that e and the mean plus the e. So it's going to be equals our mean, which is the 79.2, minus our margin of error, and equals, again, our mean, 79.2, or if you do have it on Excel like I do, you can just click the 79.2, it's perfectly fine as well. And then plus our e will get us our upper bound. So back over to the notes, we had that our interval was 75.19, or I should say 0.20 if we go and round it to 2 decimal places, all the way to 83.20. So lastly, our conclusion. Remember, our conclusion is just fill in the blank. So, with the level of confidence we have, which was 90%, confidence, we can say that our parameter, so the mean math test score, is between our interval, so 75.20 and 83.20. And that's it. So again, everything was almost the exact same as the last set of notes. Only difference is we did confidence.t and used the sample standard deviation. That's it. So let's try another one. So a survey samples 20 random students to see the average age of students at San Jac. The survey finds that the 20 students have a mean age of 23.2 and a sample standard deviation of 3.4. If the ages of students are approximately normally distributed, construct a 95% confidence interval for the mean age of students at San Jac. Alright, so we're going to go through Panic again. So first off, P is our parameter of interest. That would be the mean age of students at San Jac. A would be our assumptions. So it is random. Our sample size is not greater than or equal to 30, but it is normally distributed. And then lastly, we do not know the population standard deviation. We know the sample standard deviation, so sigma is unknown. So if sigma is unknown, that means for the name of our test, we are going to be doing the t-test. All right, I is our interval. So if we head back to Excel, again, I have everything already written down in Excel just for your convenience while you're watching the video. So the mean was 23.2, the sample standard deviation was 3.4, number of samples we had was 20, and the confidence interval was 95% or 0.95. So again, we're going to need that alpha, so I'm going to go ahead and do equals 1 minus the 0.95. So it's 0.05. For our E, we do equals confidence dot T of our alpha, so 0.05. Our standard deviation, so 3.4, and the size, 20. All right, there is our E. So now we're going to be doing the upper and lower bounds. All right, so for the lower bound, it's going to be equals our mean, 23.2, minus our E. For the upper bound, it's going to be our mean of 23.2 plus our E. So if we take this back over to the notes, then for our interval, we got 21.61 all the way to 24.79. Now we're ready for our conclusion. So our conclusion is with 95% confidence, we can say that our parameter, so the mean age of students at Sanjak, excuse me, students at Sanjak is between our interval, so 21.61 and 24.79, and that would just be years old. All right, one last example. A study asked 41 random people how fast they fall asleep. The study showed that the mean time was 7.2 minutes, with a sample standard deviation of 1.4 minutes. Construct a 99% confidence interval for the mean time for a person to fall asleep. All right, so first off, our parameter is the mean time for a person to fall asleep. Our assumptions, it is random. It is not normally distributed, but we do have 41 people, so our N is greater than or equal to 30. And lastly, we have a sample standard deviation, so our population standard deviation, sigma, is unknown. So name our test. If sigma is unknown, we're doing the t-test. All right, time to find our interval in Excel. Again, the numbers are here just for your convenience. So the mean was 7.2 minutes. Our sample standard deviation was 1.4 minutes. The number of samples we had was 41, and our confidence interval was 99%, so 0.99. So to get started, let's go ahead and do equals 1 minus c to get 0.01. For our margin of error, it's going to be equals confidence dot t of our alpha, which we just said was 0.01, our standard deviation, which is 1.4, and our size, which was 41. And we get our E right here. For our lower, it's going to be equals our mean of 7.2 minus our E. And for our upper, again, our mean of 7.2 plus our E. And we can take that back to the notes to finish this problem off. So our interval was 6.61 to 7.79. So last step, do our conclusion. So it's going to be with 99% confidence, we can say that the mean time for a person to fall asleep is between 6.61 and 7.79 minutes. All right, and with that, that's the last example done. No extra stuff for this notes. So it's just remembering that if you do not know the population standard deviation, you do the t-test instead, which just means you do confidence.t in Excel. All right, that said, that is all for these notes. So I will see y'all next time. Bye, guys.